60 years after Charles Lindbergh's solo flight across the Atlantic, a replica of his Ryan monoplane, the Spirit of St. Louis, lands at the same French airfield used by Lucky Lindy in that historic flight. At this French airfield today are some of the world's most sophisticated aircraft. In the spotlight, as the curtain goes up on the Queen of Air Shows. This is Le Bourget, France, the 37th Salon International de l'Aéronautique et de l'Espace, the Paris Air Show 1987. The first Paris Air Show was held at the Grand Palais, just off the Champs-Élysées in downtown Paris. 78 years later, here at Le Bourget, where the show has been held since 1953, this international event has broken all previous records for interest and participation, clearly demonstrating the importance of this exhibition to the international aerospace community. This year's 9-day event, with 31 nations participating, was truly international in scope. For a single major corporation, the cost of coming to the show and taking part in the exhibition can easily reach into the millions of dollars. And each air show adds some $350 million to the Parisian economy. Over the decades, the Paris Air Show has become the centerpiece in the worldwide marketing and sales of aerospace products. For those who were here, the Salon provided the opportunity to see firsthand the aerospace products of countries from around the world, including the Soviet Union and the People's Republic of China. The exhibits covered acres of space in the exhibit halls and on the static line and in the air. The weather was poor through most of the show, and although the flying exhibits were constrained because of it, the drama and the excitement remained. From the re-engined Israeli aircraft industry's Super Phantom to the Dassault Breguet Rafale and the British experimental aircraft program EAP fighter prototypes going head-to-head in their all-out performance routines, to the high-G turns flown by a General Dynamics F-16C, and the pair of McDonnell Douglas CF-18s from the Canadian Air Force. The viewers, as always, were thrilled by the spectacle of flight. As the jets thundered overhead, the real business of the show was conducted in the privacy of the chalets which lined the main runway. Security was tight and well managed. For almost 2 weeks, these crowded hospitality suites became the de facto operational bases for the leaders of the world's aerospace industries. Here, the discussions dealing with the future of the industry, the competition, and the benefits and risks of international cooperative efforts. The Airbus A320 was one of the symbols of successful international cooperation at this year's Paris show. The A320, which had made its first flights only 4 months before the show, was making its public debut here. The A320's digital flight control system was developed and tested in the A300 fly-by-wire testbed, which appeared at last year's Farnborough Air Show. Pilot input to the A320's flight control computer is via a side-stick controller. The aircraft's computer automatically adjusts both the aircraft's flight control surfaces and engine throttle settings to prevent stalling, especially in terminal phase maneuvers when the aircraft is vulnerable to wind shear. The 25,000-pound thrust engines now in use on the A320 are produced by CFM International, a cooperative venture between General Electric and the French company Snecma. Ron Welsh, General Manager for General Electric's Aero Engine Company and a Vice President of Marketing and Advanced Applications for CFM International.
The various forms of partnership can start out with revenue sharing and then progress themselves into a full-blown partnership, as is the case of CFM International, or as is the case of a recent partnership that General Electric and the Garrett Corporation of the United States formed for the CFE engine. Many of these partnerships have problems in that if you have a relationship in the sense of cooperation, but at the same time find yourself competing in other product lines, it makes it very difficult for the partnership to work, which is precisely what happened with General Electric relationship and Rolls-Royce.
The A320 is part of a family of medium and long-range aircraft that Airbus has designed. There were a number of civil aircraft making their first appearance at Le Bourget, some making their first public flights. The British Aerospace Civil Aircraft Division's Advanced Turboprop, ATP, made its first Paris Air Show appearance this year. The 64 to 72-seat ATP offers regional airlines a combination of low-cost and low-noise operations into municipal airports. The ATP is powered by two fuel-efficient Pratt & Whitney PW124 engines. The British Aerospace 146-300 made its public debut at Le Bourget, a 112-passenger regional carrier using the same four AFCO-Lycoming turbofan engines as the earlier -100 and -200 versions. The 146-200 in Continental Airline colors was on static display throughout the Paris show. In the exhibit halls, British Aerospace showed scale models of the militarized -200 versions, featuring a side-loading ramp that can be stowed or deployed in 30 seconds. Fokker BV from the Netherlands presented two new transport aircraft. The Fokker 50 is a 50-passenger twin turboprop that uses the same PW124 power plant as the British Aerospace ATP. The Fokker 50's design is based on the very successful Fokker F-27 Friendship airframe. The Fokker 100 uses two modern Rolls-Royce Tay turbofans and a highly efficient low wing to provide operational economies in the 100-passenger regional aircraft market. The Claudius Dornier Seastar, short takeoff and landing amphibian utility aircraft, was right at home in the wet skies over Le Bourget. The Seastar is the result of a private venture which sustains the illustrious Dornier name. The original Seastar prototype flew in 1984, and this new design reflects the final configuration chosen for the aircraft. The all-composite airframe utilizes a redesigned hull and sponsons, an enlarged fuselage and new landing gear. The Seastar is powered by two Pratt & Whitney Canada PT 6A-112 turboprops. Dornier expects to complete certification work by the end of 1988. The operating efficiencies and quietness of turboprops are also being applied to the next generation of business aircraft. At Paris, the Beech Starship 1 and the Ronaldo Piaggio P180 Avanti both showed a flair for the future, with designs which at first glance look similar, but in reality differ substantially. Production versions of the Piaggio Avanti will have a gross weight of 12,500 pounds. About 19% of the structural weight will be composite materials. The Beech Starship will weigh about 14,000 pounds and will be entirely composite in structure. The Avanti is powered by a pair of Pratt & Whitney Canada PT 6A-66 turboprops. The Starship uses Pratt Canada's similar -67 engines. The canard of the Starship 1 has a variable sweep for optimal high and low speed handling. In slow-speed situations, the forward aerodynamic surfaces of both aircraft will stall first, causing the aircraft's nose to drop before the main wing stalls. During the flying displays, the Starship pilot made tight, highly banked turns to show the wing geometry of his aircraft to those on the ground. The Avanti's canard is fixed and the airframe conventional metal. The decision on the airframe was made because Piaggio had little experience with structural composites for load-bearing structures. Both the Avanti and the Starship are designed to cruise at about 400 miles per hour. The afternoon before the show opened, those already on hand at Le Bourget witnessed the dramatic arrival of the United States Air Force Rockwell International B-1B long-range combat aircraft. The B-1's 11-hour flight from operational SAC deployment at Dyess Air Force Base in Texas was Class 1, no discrepancies. After approaching Le Bourget from the east, the B-1 made a pass over the north runway. Before turning away to prepare for approach and landing. Following rollout, the bomber taxied to the end of the runway and then turned toward the static line staging area. From there, it was towed to its exhibit space under the watchful escort of the French guards. The bomber conveyed an awesome and singular sense of purpose. Here, in one vehicle, is some of the most sophisticated and expensive military technology in the world today. And unlike its neighbors on the static line, this plane is decidedly not for export. Nearby the B-1 sat a European strike aircraft that is sold for export. Although the Panavia Tornado Interdictor Strike Aircraft, or IDS, is nuclear capable, it is shown here with the range of conventional munitions it can carry. For Britain, Germany, and Italy, which build it, the Tornado is a medium-range, transonic, low-level nuclear strike aircraft, suitable for intra-European theater operations. The aircraft is also flown by the air forces of Saudi Arabia and Oman. In the flying display, Panavia featured the IDS, with a typical air-to-ground ordnance payload. The Tornado's two German Turbo Union RB-199 turbofan engines produce 16,000 pounds of thrust each. In a slow-speed pass, the Tornado had its wings extended. In the high-speed passes, its wings were swept. France did not participate in the Tornado program. Instead, the country chose to develop further the Mirage family of aircraft, which the Dassault company has been building since the mid-1950s. The Mach 2 Dassault Breguet Mirage 2000N all-weather low-level two-seat penetrator is the primary tactical nuclear strike aircraft in the French Air Force. Powered by a single Snecma M53F turbofan, this nuclear weapon system combines the two-seat airframe of the operational Mirage 2000B trainer with a nuclear warhead contained in the Aerospatiale ASMP ramjet-propelled missile. The single-seat version of the Mirage 2000 also uses a digital flight control system. Alongside the air inlets, small strakes smooth the airflow over the delta wing at high angles of attack. The twin-engine Mirage 4000 is a technology demonstrator which incorporates aerodynamics and materials developed after the Mirage 2000 program was underway. It has two Snecma M53F turbofans, twice the power of the Mirage 2000. In designing the Mirage 4000, Dassault utilized advanced computer codes to establish the control surface relationships between the delta wing and the canard, which replaces the strakes of the Mirage 2000. For Dassault, the computational fluid dynamics database, derived from research done on the Mirage 4000, later proved useful in establishing the control surface configuration used in the twin-engine Rafale fighter prototype. The British Aerospace Experimental Aircraft Program, EAP fighter prototype, also uses a Delta Canard layout. The EAP was making its debut outside the United Kingdom. This was the first chance for the observers to compare the maximum performance capabilities of the two aircraft. The Rafale and the EAP are both candidates for the next generation European fighter aircraft. Both of these aircraft made their public debuts last year at the Farnborough Air Show in England. Their flight demonstrations were even more spectacular at this year's Paris exposition because both of the European aircraft had further expanded their flight envelope since Farnborough. This time, however, the two were met by two dynamic American-built entries. The U.S. Air Force General Dynamics F-16C, the latest version of an aircraft that has been performing at Paris since 1975, and the Canadian Air Force McDonnell Douglas CF-18, the prototype of which first appeared at Paris in 1977. Although many spectators looked on the performances of these aircraft, and especially the two European fighters, as a competition, there were some important differences among them. France's Rafale prototype is close to the weight and configuration of the aircraft that is expected to be built for the French Air Force starting in the mid-1990s. For the time being, the aircraft is powered by two U.S.-built General Electric F404 engines until appropriate French engines can be developed and built. The combination of aerodynamic design and high thrust-to-weight ratio give the Rafale vertical performance and horizontal maneuvering capabilities not previously seen in Western European fighters. The aircraft also exhibited good slow speed stability and excellent short landing capabilities. Britain's EAP demonstrated many of the same excellent characteristics. But because it is strictly a technology demonstrator, the aircraft weighs considerably more than an actual production aircraft in this category would weigh. In addition, it is powered by two 16,000-pound thrust Rolls-Royce RB-199 engines of the type currently in production for the European Tornado fighter. An eventual fighter derivative of the EAP would be powered by newer generation, higher thrust RB-199s or other versions of this engine. Although these factors put the EAP at a slight disadvantage in terms of thrust-to-weight ratio and overall performance, the aircraft still demonstrated in its vertical maneuvers, its high turn rates, and its slow speed stability that it indeed represents the new generation of fighter technology. Despite the fact that they are more mature aircraft that have seen operational service for nearly 10 years, the F-16 and the F-18 showed why they have become the standards for comparison. The General Electric F-110 powered F-16 demonstrated its significant vertical performance capabilities with 2.5 loops immediately after takeoff, impressive agility in its horizontal maneuvers, and its substantial energy margins with its immediate pull-up to a nearly vertical climb after a slow speed pass down the runway. The F-18, powered by two of the same GE F-404 engines used on the Rafale, demonstrated many of the same vertical climb and horizontal maneuvering capabilities. The most impressive maneuver presented by the F-18, which was flown by operational Canadian Air Force pilots, was the square loop, in which the aircraft literally turned square corners to define a box rather than a circle in the airspace over Le Bourget. Heavy vortex trails from condensation off the F-18's leading-edge extensions could be seen throughout the aircraft's flying displays. With the stunning performances of today's fighters still a fresh memory, take a look now at the flight routine of a rather unusual F-4 Phantom. Lifting off with about 20% less runway than an ordinary F-4, the Israeli aircraft industry's Super Phantom is powered by a pair of Pratt & Whitney 1120 turbofans, giving a 15% to 25% increase in thrust and range over the old GE J79 engines. The IAI Phantom was originally a test bed for propulsion work on the new Israeli Lavi fighter. The Super Phantom upgrade includes the new engines, an integrated avionics suite with dual redundant computer buses, a high-resolution Norden radar, and a wide field of View Kaiser head-up display. The aircraft has been rewired, reducing the number of electrical harnesses from 500 to 300. The result of this upgrade is an aircraft capable of 20% shorter takeoff rolls, 15% higher turn rates, 30% faster acceleration, and nearly double the payload at transonic speeds.
The new engines are treated.
The rapid evolution of aircraft technology poses a new set of challenges for the pilots of tomorrow. The increasingly complex variety and capabilities of onboard systems demand that new pilots receive more schooling before they even enter flight training, let alone become active duty pilots. A number of military flying trainers, training systems, and even training philosophies have emerged to meet this need. For years now, military pilots have begun their training cycle with a preliminary trainer like the Finnish Valmet L90TP Redigo. These aircraft are simple, reliable, and inexpensive to operate, and they feature side-by-side seating for safety and access to common flight controls. Another primary trainer is the German Fan Trainer. Trainers like the Redigo and the Fan Trainer are used to introduce pilot candidates to the fundamentals of flight and to weed out those who can't cut it. The next phase in training usually involves a basic turboprop trainer like the Tucano and this Pilatus PC-9. When the pilots demonstrate required performance standards in these aircraft, they move on to the primary jet trainers. At this year's show, the Promavia Jet Squalus NGT, or Next Generation Trainer, made its public debut. The first prototype had flown only 5 weeks before and had logged only 40 hours of flight time. Another trainer in this category is the French Microjet 200B. It has been exhibited in the past at both the Paris and the Farnborough air shows, but it was being marketed with renewed intensity at the Paris show this year in light of the U.S. Air Force requirement for a new primary jet training aircraft. Closely competitive in terms of cost and performance is the Argentine IA-63 Pampa and the CIA Marchetti S-211 single-engine trainer. At the high end of the cost and performance envelope is the Aeromachi MB-339. The French-German Alpha Jet, and the British Aerospace Hawk. All three of these aircraft were demonstrated carrying various air-to-ground weapons and performing flight demonstrations that reflected their combat capabilities. The Hawk family of two-seat trainers has spawned a single-seat attack jet called the Hawk 200. It was making its public debut at the Paris Air Show. In the case of the Hawk 200, the weight savings of removing one seat permits carrying a greater weapons load. One of the requirements for new trainers is to carry sophisticated cockpit avionics, which closely resemble the cockpit displays found in frontline tactical military aircraft. Other exhibits in the halls at Paris this year demonstrated the efforts of many companies today to help prepare personnel to operate and maintain the advanced aircraft which will come online in the 1990s. The Educational Computer Corporation of the U.S. was exhibiting an F-16 engine operation simulator. Each of these simulators costs about $50,000, but their purpose is to train ground maintenance personnel how to start up and cycle an F-16 engine and deal with any emergencies, all without actually risking the $4 million engine of an F-16 in the process. Throughout the exhibit halls, it was evident how much the computer has become the link between man and machine. The use of computer graphics and advanced flight simulation systems has continued to evolve toward greater image quality for the money. The Red Diffusion Company was showing a videotape in its exhibit booth demonstrating the new NovoView SPX simulation system, which is the result of a technical collaboration with the Evans and Sutherland Company. The NovoView SPX will be used in the flight simulators built for the U.S. Navy's T-45 training system. pilots of the future will see synthetic imagery like this, both in simulators and in actual aircraft during flight. Today's pilots watch video displays in their cockpits, seeing everything from the weather ahead of the plane to forward-looking infrared images as they fly at night. Tomorrow's aircraft will have advanced computers capable of operating at such high speeds and with such massive memories, they are being referred to as pilot associates. They will pre-sort and combine the sensor output data from systems like radar, infrared, and millimeter wave, synthesizing the raw data into meaningful visual information. This imagery will be projected right into the pilot's eyes by systems like the British GEC Avionics Cat's Eyes, which were being exhibited by Helmets Limited of Britain on one of their Kevlar Alpha Flight helmets. A similar helmet system for use in training was exhibited by CAE Electronics of Canada. One of the design challenges for optics designers is to make these display systems light enough to be used during high G turns without breaking the pilot's neck, especially if he has to eject. To prepare pilots for the rigors of high G flight, Austria Metall was exhibiting a scale model of their human centrifuge system. On both the military and civil sides of aerospace technology, the Paris Salon is a marketplace for the complete range of air and ground systems. Hispano Suiza exhibited a model of the trap-type thrust reversers which it is making for the Airbus A320. These are the first trap-type reversers to ever be installed on a civil transport aircraft. The Recaro Seat Company displayed their latest designs for airliner seating. Another seating demonstration was given by Boeing inside their cabin mock-up of the proposed 7J7 150-seat commercial transport. At the Honeywell stand, the Sperry wind shear system was being displayed. This is the first FAA-certified wind shear detection system for the air transport market, and the only wind shear detector that can spot the hazardous microburst condition before the aircraft is actually in it. Sperry was also showing the state-of-the-art Gulfstream 4 cockpit. General Dynamics brought a $50,000 model of a land-mobile high-value site defense variant of the company's famous Phalanx shipboard terminal defense system. Boeing Verthal was showing conceptual models of possible future variants of the V-22 Osprey tilt-rotor aircraft. The People's Republic of China's presence was significantly expanded from previous years. Their characteristically simple but interesting exhibit stand displayed models of the full range of Chinese missiles, including the ramjet-powered supersonic HY-3 shore-launched anti-ship weapon system. Visitors to the Chinese stand also saw models of the Long March Space Launch System, which is being actively marketed to Western satellite customers. Outside, on the static line, the Chinese showed 3 aircraft, marking the first time that the country has brought domestically produced aircraft to the show. The 2-seat Xi'an FT-7 is a trainer and attack aircraft. It is derived from the Soviet MiG-21U. This FT-7 is equipped with a centerline 23mm gun pack. The Qiang A-5C ground attack fighter bomber is also based on a Soviet design. This MiG-19 derivative is capable of carrying both air-to-ground and air-to-air weapons. External stores on display included a rocket pod and fuel drop tanks. The Harbin Y-12 turboprop commuter transport is a 17-passenger airplane powered by 2 Pratt & Whitney Canada PT-6 engines. A number of aircraft from the Soviet Union were also at the show. The Antonov 124 Ruslin, or Condor as it's known in NATO circles, was present, dwarfing all other aircraft exhibited at the show. This year, the largest aircraft in the world was joined in the flying by a new Antonov design, the AN-74 Short Takeoff and Landing Arctic Transport Aircraft. Its wing-top-mounted engines induce a low-pressure Kawanda effect on the wing to generate lift. The AN-74 is a stretched version of the AN-72. The Soviets plan to build more than 1,000 Antonov 28 twin turboprops to replace Aeroflot's aging fleet of AN-2 biplanes. In the Soviet exhibition hall, the Tupolev Design Bureau showed a cockpit concept which they are examining for use in the future Tu-204 transport. The Soviet Union also had on display in their hall full-size models of their current turbofans. And we spoke with a member of the 160-person Soviet delegation, Mr. Vladimir Rashupkin.
Well, those two engines, the first one, D-18T, it's installed already on this large plane, which is called in Russian Ruslan, and here Condor. It was flying yesterday, I suppose, successfully. It's in operation almost 3 years. Well, and I suppose he had a good characteristics. This new plane have already put two at least world records, one of cargo lifting, 170 metric ton, it's the world record, and the second record of a long-range flight. It's, if I'm not mistaken, 20,050 kilometers approximately around all the borders of the Soviet Union. Well, I suppose a month before this show. Well, and the second one, the Solovyov's D90, it's a quite new engine. It's under development now. It is tested on the rigs and on the flight laboratory, and it is going to be certified in the beginning of the next year.
The Soviet Hall was filled with examples of this country's achievements in air and space. The Mir space station dominated the exhibit. The configuration on display showed the Soyuz TM Crew Transfer Vehicle, the Mir Station Module, a Kvant Astrophysics Module, and a Progress Resupply Vehicle. Underneath the space station, a Soviet spacesuit, and a Soyuz-type re-entry capsule showing signs of charring from actual re-entry. Inside the capsule, a Splav-2 crystal growth facility was visible. This technology represents the Soviets' latest commercially available space processing capabilities. In the center of its exhibit, the Soviet Union exhibited a full-scale replica of the large Phobos spacecraft, named after the moon of Mars, to which it will be launched in July of 1988. The modular Phobos features a hopping lander that will hop from one survey site to another on the surface of Phobos. A collection of subscale models of past and future Soviet aircraft, clearly suggesting the direction that Soviet aircraft designers are taking. A new prototype piston-powered sport and training helicopter, the Mi-34, stood behind the models. The Aerospatiale Panther demonstrated in its flying displays the improved performance capabilities of helicopters and the increased reliance on these aircraft to serve in multiple military roles. Another helicopter, shown in full-scale mock-up form at the show, was the Eurocopter, which is a joint program between France and Germany. The Augusta A109, shown here in static display, was equipped with both anti-tank rockets and side-mounted electronic support measure antennas. A mock-up of the Augusta A129 carried on its roof a pulsed infrared countermeasures device, which protects the aircraft from heat-seeking missiles. A full-scale mock-up of the battlefield support version of the Augusta A129 was also displayed this year for the first time at Paris. The Mangusta is designed to perform anti-armor and area attack missions day and night under instrument and light icing conditions. The U.S. Army McDonnell Douglas AH-64A Apache attack helicopter was also at the Paris Air Show. Following the Salon, this production model was slated to join more than 200 other Army Apaches based in Europe. The Apache is competing with the Eurocopter to meet the German Army's requirement for a new anti-armor helicopter. A number of aircraft at this year's Salon did not fly, but were exhibited only in the static display. The EH Industries is a joint venture between Augusta and Westland, exhibiting a full-scale mock-up of its 31,000-pound gross weight EH-101. The Omnipol L410 UVP civil transport provided a glimpse of Czechoslovakia's aircraft manufacturing capabilities. The Franco-Italian ATR-42 transport was shown in Pan Am colors.
This aircraft, which performed the first transatlantic flight in solo in April 1927-28.
This replica of the famous Ryan monoplane, the Spirit of St. Louis, wasn't the only aircraft marking or making records during the air show. A Gulfstream 4, flown by Gulfstream CEO Al Paulson and a 5-man crew, left Le Bourget and flew around the world, westbound, before returning to the air show with 24 records, including 2 world-class speed records. This was the first time in history that such a speed record had ever been attempted westbound against prevailing winds. The flight of the G4 lasted 45 hours, 25 minutes, and 10 seconds. Just 7 minutes under the standing eastbound world time record, which is held by a Gulfstream 3. During its 23,000-mile journey, the Gulfstream 4 made 4 refueling stops. The average flight speed was 556 miles per hour. Another record was set at the show when this Piper Malibu Arctic Tern arrived, following its completion of a polar circumnavigation of the Earth. As usual, visitors were treated to some of the perennial activities and aerial displays of international air shows. One of the more dramatic sights during the public days was that of the Anglo-French Concorde, escorted in flight by members of the French Patrouille Precision Flying Team. Development of the Concorde in the 1950s and 1960s helped France and Britain establish the broad expertise in aerospace systems engineering, which they have since applied to other air and space systems. Inside the exhibit halls, this broad expertise was characterized in this display of aerospace products, manufactured entirely or in part by just one French company, Aerospatiale. Among these models, Aerospatiale was showing 2 concepts for next-generation supersonic and hypersonic aircraft, which might be built by the company after the turn of the century. The Soviet Union displayed a model of their 300-passenger hypersonic transport. The aerodynamics of Germany's MBB transport division's HST-230 appear to have the most sophisticated computer modeling of any concept shown in the various exhibits. British Aerospace displayed a scale model of the company's concept for a horizontal takeoff and landing HOTOL aerospacecraft. The configuration of HOTOL shown here differed from earlier ones, notably with changes in the multi-cycle Rolls-Royce engine air inlets. Until these exotic reusable systems are available, space launches will still be accomplished primarily by expendable rockets like the Japanese Mitsubishi Company's H-2 Heavy Booster, which is the same class of launch vehicle as the French Ariane 5. The Ariane 5 will be the booster for a partially reusable space launch capability in the 1990s, built around the reusable boost glide technology of the French Hermes shuttle. A full-scale model of the Hermes was exhibited by CNES, the French National Space Agency. Philippe Couillard, the director of manned spaceflight and the Hermes program manager for the CNES, discussed the program and its relationship to expendable launch systems.
Hermes cannot be dissociated from Ariane 5 because on Hermes there is no gross propulsion. So gross propulsion is given by the launcher, the Ariane 5 launcher. And so Hermes use the first 2 stages of Ariane 5, which are exactly the same as they are for automatic launches. And this is so a different concept, different approach for Hermes Ariane 5 compared to the shuttle approach. We are not obliged to put men on board to launch telecommunication satellites. We put Hermes only when man is necessary to be put in orbit.
Germany's MBB displayed a model of a fully reusable space launch system. The MBB Zanger is a two-stage space launch system concept, which combines a ramjet-powered hypersonic first stage with a rocket-powered orbiter called Horus, which interestingly is projected to be about the size of the current Hermes. Ernst Hugenauer, MBB Zanger program director, commented on relationships of the existing technologies such as Hermes and concepts like Zanger.
Okay, let me start with Hermes. Hermes stays for the non-executed European homeworks in the area of technology within the last 20 years. So, the answer is here very clear. We have to do our homework in the area of aerodynamics, re-entry, etc., etc. That's the key for all the future programs. Now, where stays HOTOL? HOTOL stays for a very, very advanced propulsion system. But from the engineering standpoint, it takes years. It takes at least 1 or 2 decades to develop such a fantastic engine. So when we look to a Zanger, it's more realistic because we are proposing a system where the first stage is propelled by a ramjet. And this ramjet reaches a velocity range up to Mach 5. And then we get the separation of the 2 stages, and the second stage is driven by a conventional rocket system. So I think from the engineering standpoint, we have a system concept which is really feasible for the next, let's say, 10 to 15 years.
As the participants at this year's Paris Air Show left Le Bourget to return to their homes, each carried with them a sense of what the air show meant to them, their companies, and their nations. One of the early departures also turned out to be one of the most watched. The return of the B-1 to its Strategic Air Command assignment at Dias Air Force Base was delayed 1 day due to a problem with the onboard auxiliary power unit, which made it impossible to start the engines. A military standard power cart had to be flown in from Germany to correct the problem. After an additional delay for clearance, the B-1 finally got the go sign. The B-1 made a slow-speed pass at about 300 knots with the wings extended. The aircraft commander then swept the wings, accelerated, and circled to make a high-speed pass at 560 knots. The nose of the B-1 then rose to a 45-degree angle, and the bomber climbed at a rate of 20,000 feet per minute. And vanished. Another great memory of Paris, 1987.